Once the sterilization and cooling processes are complete, the cans proceed to the designated labeling area, where they receive product information, brand logos, and comprehensive nutritional data. This is followed by systematically encasing them in cardboard containers for distribution, a procedure executed either through manual labor or automated systems. To guarantee structural integrity during transit and handling, the cartons are secured with adhesive tape. These boxed units are then organized onto pallets in preparation for shipment, where they are finally loaded onto transport vehicles for immediate distribution. If you're fascinated by the journey of how food goes from farm to table and want to learn more about the production of other foods, be sure to watch. When fishing for sardines, fishermen use lights at night to attract the fish to the surface. These lights imitate the natural glow of the sardine's food, making it easier to catch the fish. The net used to catch the sardines is a seine net, specifically designed to encircle and capture entire schools of sardines efficiently. As it is pulled on board, the sardines are directed from the angled surfaces into large storage containers filled with ice. This process is important for preserving the fish's freshness during transportation to the processing facility. Upon arrival at the processing facility, the sardines are removed from their packaging and placed onto various machinery systems. These fish will undergo a comprehensive washing process using cold, fresh water, which effectively cleanses them of impurities, scales, and any residual contaminants. Concurrently, in a distinct section of the facility, an automated system prepares the rectangular tin cans and corresponding labels employed for sardine packaging. These containers, along with the subsequent airtight seals, are then transferred to their specified place, poised for the sardine filling process. The conveyor belt system efficiently transports the washed sardines to a designated sorting area where a skilled team of workers meticulously evaluates each specimen for size, freshness, and species classification, ensuring precise adherence to stringent quality control measures. Once the sorting phase is complete, the sardines are introduced into a machine designed to execute precise incisions and organ removal to undergo evisceration. During the entire procedure, workers diligently oversee the process to guarantee the thorough extraction of internal organs and identify any signs of contamination, promptly discarding any compromised specimens. The thoroughly cleansed and eviscerated sardines are subsequently placed into a large containment unit. The prepared empty cans are delivered to an automated filling machine via power-driven conveyors. This machine is equipped with a specialized feeding unit designed to efficiently transport sardines from the preparation area directly to the filling station. The machine contains hoppers that accurately dispense a specific quantity of sardines into each individual can. This system is calibrated to ensure uniformity in the amount of fish packed per can, which is essential for the product consistency. Subsequently, the cans undergo a sealing process utilizing automatic seaming machines. These machines meticulously create a vacuum seal, an essential feature for preventing contamination and spoilage. Depending on the specific product needed, sardines can be processed in a different way. Once the sardines are delivered to the plantation site, they undergo a thorough inspection where any damaged or low-quality fish are removed. The sardines are washed, and skilled workers manually gut the fish, extracting entrails, heads, and tails with precision. The prepared sardines are then manually filled into the tin cans. These open cans are subsequently grouped together, enveloped in a fenestrated material, and conveyed to the pre-cooking section, where they undergo a process of boiling and steaming, the aim of which is to maintain the firmness of the flesh while enhancing flavor. Following the pre-cooking process, the sardines are filled with sardine oil, which serves both to enhance their flavor profile and to maintain their preservative qualities. Advanced automatic seaming machinery is then employed to securely seal the cans, creating an airtight vacuum seal. This critical procedure is designed to prevent the infiltration of air, thereby significantly extending the product's shelf life. The vacuum-sealed cans are then subjected to intensive sterilization within industrial-grade retorts, which operate at elevated temperatures. This essential step is important in eradicating harmful microorganisms, thereby ensuring the safety and longevity of the food product. In the processing of larger sardines, specialized personnel meticulously examine each fish to identify any flaws or imperfections. At the same time, larger cylindrical tin cans are methodically prepared and conveyed to their respective destinations. The sardines are then transferred to a designated area where they undergo evisceration, which is facilitated by an automated machine. Once the removal of internal organs and heads is done, the remaining parts of the fish are thoroughly washed in preparation for packing into the appropriate tin cans. The prepared sardines are filled into the cylindrical containers, either through manual methods or by employing an automated filling apparatus. Following this, the unsealed sardine cans undergo a preliminary cooking process, during which they are subjected to steaming. The cans are now sealed using an automated seaming machine, which establishes a vacuum seal before being conveyed into a sterilization unit. In the manufacturing process of sardines, alternative fillers, such as tomato sauce, instead of the traditional options like oil or brine, can be utilized as the liquid medium for preservation. vacuum-sealed bags to bulk containers. High-speed packaging machines fill, seal, and label the packages efficiently. Throughout the entire process, rigorous quality control measures are in place to test for quality, moisture content, and contamination, ensuring a high-quality product. Once the walnuts are securely packaged, they are prepared for distribution. The packaged walnuts are carefully loaded onto pallets and transported to the warehouse using automated guided vehicles or forklifts. The integration of advanced automation technologies in the packaging process significantly boosts efficiency and reduces labor costs. Robotic arms and conveyor systems ensure precision and speed, while high-speed packaging machines guarantee consistency and quality. Once packaged, the walnuts are efficiently stored and managed in the warehouse, ready for distribution. Walnuts are popular due to their rich nutritional profile, offering a source of healthy fats, protein, vitamins, and antioxidants, making them a convenient and versatile. Walnuts fields are typically vast, covering hundreds or even thousands of acres, where trees are planted in well-organized rows to maximize space and sunlight exposure. The trees, which take several years to mature and start producing nuts, are meticulously maintained to ensure high yields. The primary equipment used to harvest walnuts is a mechanical tree shaker. These machines are designed to grasp the trunk or main limbs of the walnut trees and shake them vigorously. The shaking action, which is carefully controlled to avoid damaging the tree, causes the ripe walnuts to fall to the ground. The machinery is equipped with padded clamps and adjustable shaking settings to cater to different tree sizes and conditions. After the walnuts have fallen to the ground, the next phase of the process involves clearing the orchard floor. Mechanical sweepers or blowers are used to gather the walnuts into rows, making them easier to collect. This equipment ensures that most of the nuts are efficiently moved to a central area, minimizing the need for manual labor. Specialized harvesting machines, known as harvesters or pickup machines, are deployed. These machines are equipped with belts or brushes that pick up the walnuts from the ground, along with any leaves or debris. The collected walnuts are then transferred into large bins or trailers. These containers are subsequently loaded onto huge trucks for transportation. The trucks carry the walnuts to processing facilities where the nuts undergo further cleaning, drying, and sorting. When the trucks arrive at the processing facility, they release their load of walnuts onto a designated receiving area. This spot typically consists of a large grate or set of bars that allows any remaining dirt and smaller debris to fall through while the walnuts are retained. From this initial receiving area, the walnuts are elevated to higher platforms via a system of conveyors. These conveyors transport the walnuts through various stages of processing, ensuring a continuous and efficient workflow. The first major step in the processing facility is the thorough rinsing and washing of the walnuts. Large industrial-grade machinery is employed to remove any remaining soil, leaves, and other impurities. The walnuts are subjected to rigorous mechanical agitation, which helps dislodge stubborn dirt and debris. This initial cleaning phase is critical to ensure that the nuts are as clean as possible before moving on to more refined washing stages. Following the initial cleaning, the walnuts are rinsed with high-pressure water sprays. These sprays are designed to reach every part of the walnut, providing a deep clean that eliminates any remaining dirt. As the walnuts move along the conveyors, they pass through multiple spray zones, each equipped with jets of water that ensure comprehensive rinsing. This step also helps in removing any potential contaminants that might have adhered to the walnuts during their journey from the orchard. Human workers play a crucial role in the next stage of the process. Positioned along the conveyor belts, these workers visually inspect the walnuts as they pass by. They are responsible for sorting and checking the walnuts, removing any that are damaged, discolored, or do not meet quality standards. The walnuts are then moved to a large storage area within the processing facility. This storage space is designed to accommodate vast quantities of walnuts, ensuring they are kept in optimal conditions until they proceed to further processing or packaging. The facility is typically equipped with large bins, silos, or storage rooms where the walnuts can be held. These storage areas are climate-controlled to maintain the ideal temperature and humidity levels, preventing the walnuts from spoiling or losing quality. Proper ventilation is also crucial to ensure that the walnuts remain dry and free from mold or other contaminants. The storage space is often organized to allow for easy access and efficient management of the walnut inventory, facilitating smooth transitions to subsequent processing stages. The walnuts undergo automated scanners that use optical sensors, X-rays, or laser systems to precisely evaluate the size, shape, and quality of each walnut. The walnuts are then sorted into different grades and sizes by the machinery, ensuring consistency and quality for each batch. For bulk packaging, the walnuts are transferred into large bags, typically referred to as super sacks or bulk bags. These bags are made from durable woven polypropylene, which is strong enough to handle the heavy weight of the walnuts and resistant to tearing. The bags are designed to hold large quantities, often ranging from hundreds to thousands of pounds of walnuts. To enhance efficiency and reduce labor costs, many facilities employ robotic arm technology to handle the heavy lifting and movement of these bulk bags. Robotic arms are programmed to pick up, move, and stack the bags with precision and speed. For mass production of deshelled walnuts intended for snacks, the walnuts are moved to mechanical crackers that apply precise pressure to crack the hard shells without damaging the nut meat inside. The mixture of shells and nut meats is then transferred to separators which use airflow, vibration, and screening to separate shell fragments from the nut meats. Multiple stages of separation ensure maximum efficiency and purity. The separated nut meats are sorted to remove any remaining shell pieces and classified by size and quality using optical sorters and manual inspection lines. Only the best nuts proceed to packaging, which varies based on the market, ranging from